Okay, welcome everybody. My name is Jônatas. I am developer advocate at Timescale and also community manager. And we are doing this as a call to action to our community, as a way that we can aggregate value with the community and try to understand the standards, how people think. And maybe we are going to also introduce a template that can be shared and can easily make more adoption in a specific segment. We are here in the tracking pair correlation, and we are going to also be covering more advanced downsampling techniques later for finance, and later also the last session will be about compression and other side effects. So that's our progress. If you want to understand more, you can also go to timescale/templates in our GitHub. You find everything that we are building here. We have some work in progress open in the sensors, and we have everything committed on the finance domain. So that's our template. I'll just walk over the template because if few folks were not here in the previous session, so you know what we are talking about, and then we can continue. So the main structure here is about market data stream. So we are going to have a ticks table, which can just track symbol price and volume. And this is our hyper table, and we will just have one partition per day. We are compressing it and segmenting by symbol, and we also put like one week as compression time interval, chunk time interval for compression settings as well. And we can compress the data after a week, and we can also build hierarchical continuous aggregates that can allow us to roll up candlesticks from the minimal to bigger time frames, and that's what we are building here. In the last session, we talked about updating last price and having a kind of metadata table which can maintain the last price of the symbol based on the ticks table. So we discussed the pros and cons of using triggering, how much it slows down the system, and how it works if we approach it in this way. And we understand like this is basically adding like 8 times more process layers if we add it. So we slow down a lot using this approach, but this approach is very granular. And then we discuss all possible ways that we can build it. So today we are going to continue the saga and talk about tracking pairs. So think that it's very common in financial markets that people just use pair correlation. So for example, you wanted to know to operate on long short strategy. So you are buying something and selling some other thing, and you can operate in these two sides. So instead of like having a win and a loss in both sides, you operate over the rate of the two different stocks or crypto and things like that. So you can just think that the operating over the rate is also a strategy for financial markets. So people need to do this, and they need to track the pairs. And here is a very, very simple function that just checks like, hey, I have this symbol table which I maintain the last price, and when I update the last price of this table, I can now create a new rate, because this can generate a new rate between the tracked pairs. So think about these chaining events that can generate new tracked pairs. And alternatively, we can also generate it in a separated hypertable. In my case, if you see here, we are doing the insert here on the ticks table. So we are retro feeding the fits this table, and that's also another strategy. So we can reuse all the candlesticks pipeline and everything from this initial example. And we have a few pitfalls here. So for example, playing with these on ticks, like the correlation doesn't have volume, so we don't need the volume there. It's just like a static one unit we are just using as a reference, but it's really not necessary. And the problem is also the combinations that maybe we don't want, and also depending on how liquid is every asset, they will have much more transactions, and they will operate in much more high frequency trading than this. So this is very hard to balance. So this approach that I showed is just like a 𝗙𝗵𝗽𝗀, very sequential implementation. And it works if you are operating over like a few dozens of pairs. But if you are operating over thousands of combinations, maybe it will be really slow and will really not worth the effort. And let's just reflect a bit on tracking pairs or like rating systems and what we want. So we have a few options. So we can query or we can cache it, right? It's very similar from last price that we discussed in the previous session. So what we can do with how we can get the last price, we can cache it or we can just query it every time we need it. And it will depend on how often I'm querying. So if I'm not querying that often, maybe it just makes sense to query it directly instead of caching. And that's what we need to be considering in this. So we start with track the pairs, and this is the function. And here you can see that if one of the elements is not present, we just skip it. So this is like a really fast check. So depending on how many pairs you are tracking, this will be costing very little. And we also will just to make new prices when we have both prices. I am considering not like going back in time and say like, oh, I just generate one track pair in case I have data in the last 5 minutes or in the last hour. So it just goes back in time. So maybe to being consistent. So this is a very naive example. And yeah, probably if you are building it for production business, you need to consider everything that makes sense for you. And that's also a lot of weakness that you see Nelson just covering the ground and making much better than this suggestion. So this is just an idea. And I was just doing some benchmarks here based in our previous session. So what we have here is single batch. Just a reminder, we are not going to be like processing. We are talking about single connection, single process. And the idea is like, hey, if I have this workload and put it in a single process to load, maybe I will also add more overhead with my trigger system, with the functions I'm triggering, with the process of retrofitting the ticks table. So how much will it be worse, or like, do it matter? So I did a small test here, and this test is the same we did in the previous week. So we are talking about 500,000 rows that we are inserting, right? So we got it in, and we are inserting 500,000 rows for 900 symbols. And as you can see here, we are operating in the 100 milliseconds. So we generate 10 events per second. So in this case, this is quite heavy. So we have we have these 900 symbols, and this is from my previous benchmarks. It's running over under 3 seconds. It's like 2.8 seconds with a single CPU. So I'm just having like one single CPU and trying this as a kind of baseline to allow us to understand, right? So this is just a table that we can refer as a way to remember how much data we are generating, right? So I don't have exactly the number because it's 10 times more than what we have in every second, because we are operating under 100 milliseconds. So, and then, oops, if you see here, we have like 4 million records if we just use 10 stocks with 1 second. So 4 million records per day. So this table is trying to show you an estimation of how many records you get per day, just in this stock correlation based in the number of stocks and the number of unique combinations. So for example, if you have 2 stocks, you have A and B, so you can just combine A and B. B to A is the same as B, A and B, so it's just an inverse correlation. So if you have A, B, and C, you can do A, B, B, and C, and C, and A, C, right? So you have just 3 combinations. So that's the idea, and you can see that it can scale quite fast. And then if you just like go into a very, let's say, low-level correlation, you have a lot of new data points in your database. So yeah, you can see here the maximum value, like if I'm combining 10,000 stocks, I have like 50 million combinations, right? So, and if I go into 1 record every hour, I still have like 1.2 billion rows. So that's a lot. And that's why I'm just like inviting you to think about what you are tracking and how you are going to massive use it or conscious use it. In my example here, I built very small case. So I will just move now to my terminal, and we are in the Timescale template folder. And here you can see finance, and you can take a look here on the main file. So just to remember, when we run it, we do like a cleanup, then we add the ticks table, then we start tracking last price, then we add the pairs system. And I was working on this pairs test here. That is where we are going to explore today. So pairs test is it's basically initially I'm just like inserting symbols and ticks. So for example, let's just make this these lines here. So if I do, oh yeah, I just did the 2 inserts, and then if I do here table ticks order by 1 desk limit 5. Oops, let's go again. Oh, I have one tiled here. So you can see here the stock A and B. Oh, for some reason, it's not showing this the time there. Probably I have a small bug here, but the main idea is that we are going to run it in a sequential way. So this is just like the smallest test that you can understand and take a look and see how it works. So I really want to have first test. I really want to have like very small examples which people can take a look. So for example, I forgot this line, so probably that's why we don't have yes, we are not there. So for example, if we try to insert now, and then we insert 2, and then now it was supposed to be there. Yeah, it's not there, so let's continue. I'm not going to stop here, but the main idea here is that we can track the symbols. I'm guessing my query is wrong there, because when we insert the ticks, we are using last price at. So maybe this is not really up to date, and that's like dragging the record back. But the main idea here is that it's also generating. So for example, if I say here table ticks, no, I need to say select star from ticks where symbol contains one slash that is our thing. So you can see here stock A and B. So you can also see the other tests I'm running. exploring pairs and combinations. So that's what I would like to show you here. So we just have the function here that we add in the previous day, that's add ticks. So it adds 500,000 of rows, and then we did like one insert of 30 symbols, and instead of just using too many symbols, and then we combine all the 30 symbols with 30 symbols. So here you can see that with like 50 we already have 1,000 combinations, so 30 is probably like 700 or something. And then these tracking pairs, I'm sorry, I can also increase the font here. So that was the main idea: insert all possible tracking pairs from like the 30 symbols, not for all, and then add ticks again. The only problem is that add ticks is adding ticks for like 900 different symbols. So you also have the overhead of like all the other market data stream not going there. So I was running these backtests here before, and I can see if this is already finished. I will just see if I can just move my terminal here, my other terminal. Yes. So and you can see here that like it takes like 6 seconds to run with the trigger, but no data, and then it takes tracking all the symbols with this small combination. It takes like 9 seconds, and yeah, so that was the case. I was just trying to say like, hey, it's adding ticks, it's confirming. So it's really adding one extra layer of complexity, and also like killing a bit of the performance. I couldn't run like a subset of like several grades of numbers to share like what is the average degradation. But in general, like depending the number of pairs and combination you have, it will not be hard, and it will be possible to just run with a very naive algorithm like this. But this is the main problem of this approach, is that it's unpredictable. So if the market goes crazy with like 1,000, 1 million events in 1 second, then you have 1 million rates for the same second. So maybe you are not like taking decision too inside the millisecond, and you can just generate it every X seconds and so on. So that's it from this side. If anyone has any questions, I will just leave it for the end of the presentation, because now we can just pass the mic to Nelson from Uphold, and he can continue here. So Nelson, stage is yours. Welcome. Mibo asked about the dataset. So the dataset, where you can get the dataset, I am generating the dataset server side via generate series. So I'm not getting any real dataset. It's just to test the insert throughput, and in a way that I don't need to have like a cloud machine and another machine in a cloud and then connect them. So I'm just making it directly in server side.
So, okay, so let's start. So hello, my name is Nelson. I work at Uphold, and I'm here to talk a little bit about how we made use of Timescale to address some requirements we had. So Uphold, yeah, you can pass the slide if you want, Jônatas. Yeah.
Mm-hmm.
Uphold is a fintech company where you can buy lots of assets, mostly crypto assets, and we had 2 main requirements. Number 1 was to track historical rates for all the currency pairs, to support drawing charts like the one you see on the right for every currency pair that we support, and for several time periods, like you can see there, 1 hour, 1 day, 1 week, 1 month, and 1 year. And we also wanted to calculate rate statistics, so open, close, high and low, for each of those rate pairs and intervals. These statistics are very useful in several places in our app. And for instance, we use them to calculate our unrealized gains and losses that we show to the users of the app. So you can pass. Yeah, okay. So we turn to Timescale to address those requirements. So in our implementation, we use a rates hypertable where we store our raw ticker data, which is more or less 3,200 rows every 5 seconds. And then so notice that we ended up splitting the from and the to currencies for each pair. So because for us it's more flexible like that, so we can, for instance, get all the pairs to or from BTC easier. That way we don't have to enumerate the pairs. So we did it like this because of that reason. Okay, you can next slide. Okay, so and then on top of that hypertable, we created a bunch of continuous aggregates, one for each interval, so a day, a week, etc. Where, okay, like I said, each bucket matches the desired resolution for the chart. For instance, in this case, we are looking at the continuous aggregate that will feed the 1 hour charts, where we want 1 point each 30 seconds. So we made each bucket a 30 seconds bucket. By doing things this way, we don't need to process anything. We just read a few hundred rows from the continuous aggregate to get historical values for the chart, and that's it. It's very, very fast. You don't need to do anything else. And then you can go, okay? So we also made use of hierarchical continuous aggregates to speed things even more. Because each of our desired intervals was a multiple of the others. For instance, this continuous aggregate, the rates materialized 10 minutes, is the one we use to fetch the values for the 1 day charts. And it builds upon the rates materialized 30 seconds one, because 10 minutes is a multiple of 30 seconds. Using hierarchical continuous aggregates, the roll-ups were a lot faster because there were less points to roll up. Then, well, those are the other aggregates we have. So, right, the 2 days aggregate is built upon the 6 hour aggregate, which is built on top of the 10 minute, which is built upon the 30 seconds. And this is how we handle the historical data for the charts. Then we have the other requirement, which is to get the rate statistics for those pairs, for those intervals. And this is not as easy as it might seem, because we don't want to rate statistics for a static interval. We want statistics for an interval that is moving relative to now. It's the last hour, not for a given hour. And that's harder. So as you can see, like from the previous slide to this new slide, the thing, so because this interval is moving, then the points that you have to consider are different. So and that's why this is tricky, and that's why the reason why our current approach is just to do this on query time. So we go we go to we roll up the buckets of the materialized continuous aggregate of the window we want. For instance, we roll up the buckets inside the last hour from the rates materialized 30 seconds to get the statistics for the last hour. This is fast enough, but if you want to do it for a lot of pairs, it starts to become a bit slow. So that's why we added a cache, so not to do this so often. And then we have an idea to improve on this. Something that we took from Jônatas' last session. Now we want to, our next approach will be to have a table, for a statistics table, that will have several jobs, one for each interval, that will read on the continuous aggregate of that interval, and will be updating that statistics table with the roll-up values, and that they will run on the background, so it will be faster for you to get the result because it will already be calculated when you need them. And that's how we are doing it. This is just like a small or a very high-level overview of what we did. I think we will have a session in the future to discuss this in more detail. I don't know if there are any questions about this, or I don't know. I hope.
Yeah, thank you very much, Nelson. And I think like the discussion we had about improving the way it works for finance in general, probably we should we are going to organize one extra session later after these sessions with Nelson, and to let Nelson lead the session and propose a few ideas that we can like create a small configuration and like orchestration of background jobs to make it much faster. So it's all around like we just need to sit down and check what comes first, what comes late, and see how we can make this streamlined version of the processing much faster than what it is now. So
yeah. Mm-hmm.
if
I even forgot one thing. Sorry,
yeah, go ahead.
Sorry for interrupting. I was talking so fast, I forgot. So we are using hierarchical continuous aggregates. We tried going with real-time aggregates, but because they're on top of each other, it was a bit slow, or kind of slow, right? Because of how real-time works. Because the last bucket needs to go to the hyper table below, and so on and so forth. So it was a bit slow, and then we worked around that by, just use materialized data that we have on the continuous aggregates, which are refreshed in the background. And then we had like the latest rate at the end, and then you never have information that is outdated in a sense, right? You always have the latest rate for the pair plus the ones that you have materialized. So that's how we solve that issue. Sorry.
No problem. Like that's a thing that maybe people will need some visuals to understand, because like this is like we talked like half hour or more about this, so it comes quite complex to just like throw it now, but we will build this session. So thank you very much, Nelson, and we hope to see more folks coming to the stage and helping us to also drive for their needs. So we really encourage more folks to come and share their case. So thank you very much. Okay, folks, so continuing here, I would like to invite everybody for the next session. We are going to talk about downsampling techniques, and that's where we can save bandwidth. We can save also a lot of memory inside the server. So if you want to go and understand more of like downsampling algorithms, how they work, and how they can optimize your queries and different strategies for being optimizing, join us on next Thursday. So I hope you also see that we are on Slack. We have this discussion, finance market data channel. And if you are not part of our Slack, join us on timescaledb.slack.com. And we want to promote more discussions. So as a community, as people using, so join Timescale Community. We have forum, we have our Slack, and we really want to dive into more and more conversations. Another work that developers relations have is just to be with people in the community. So we have office hours. If you want to book 1 hour with me or with the James, you can also book 1 hour. We can talk about any timescale usage you have. We can help on your configuration, anything. That's like one thing I love to do. Like I have these calls every week with folks. I met with Nelson twice already, and I'm always meeting with folks from the community. And this is my favorite time of the day. So if you want just to book some time, you can find my calendar or James' calendar. James in Australia, I'm in Brazil. So you can see what works better for you. So that's it for today. Thank you very much. And I hope to see you next week. Bye.